The thing here's a problem. You've got all your Skittles that you want to eat, and you want to eat all of the same colour. But to do that, you have to actually think about what the colour is. I mean, who has got the time to have to think about what that colour is? What that colour is? Who has got the time to do that? Not me. I know, I've got a better idea. Roll the titles. Is that it? So okay, yes, what we're going to look at today is actually a colour sensor to actually sense what something's colour is. In this case, Skittles. Let's just sort of get rid of them to one side for now. Rolling all over the place. And what we're going to use is this little sensor here. It's a TCS230 sensor. Yeah, that's it. TCS230 or a TCS3200. And the actual sensor part is just there, right in the middle. That little black speck is actually the colour sensor part. And basically what it is, it's an array of little individual photo detectors, however you might want to put light detectors. I think it's a 6x6 grid, I could be wrong on that, but anyway, it's an array of detectors. And over some of them, there are a red filter, over some are green, and over some are blue. And then there are also some without any filter at all. And with that combination, they can detect different components of whatever colour they're looking at, so red, green or blue. Every colour that the human eye is sensitive to is made up of different red, green and blue amounts. So for example, if we had the red Skittle, or it's more like maroon, it will be mostly red, and the green will be mostly green, and the orange and yellows are probably a combination of red, greens and maybe a bit of blue as well. So that's how it works. You can detect it by filtering out, to filtering each colour that something contains, and then you can read that back. These are basically 4 bright white LEDs, and they just shine light, so you get a nice bright illumination of your subject. So let's put it into the circuit that I've built, and there is not much to the circuit. It is incredibly simple. So just pop that back in, and then just goes there. And what I'll do, I'll pop the actual circuit on screen as well for you. We'll just angle that so it's a little bit better for the camera. And basically, if we're looking at this, we have a voltage going to VCC. There's a ground that, I know it doesn't look obvious against the ground, but this ground goes via that to that ground line there we've got there, so that's going to ground. The out is actually where the data comes, and that's going along there to D5. And ignoring these two down here at the moment, we've got S2 and S3. And basically they're controls. You raise them high, raise them low in combination to either read the red, the green, the blue, or the one where that's in no colour filter at all as well. So by sending these in a combination for highs and lows, you'll get that certain bit of colour bit data back down that outline, which you can then interpret with your Arduino. Now the actual data is not straightforward. It's actually a sequence of, well, it's a frequency of pulses that comes along, and the frequency is directly proportional to the level of that particular colour. So for example, if we set these two wires to read just the red, you get a frequency of high and lows that was in proportion to how much red it saw. Now that sounds complicated, but luckily they are libraries for us, so we don't need to worry about that sort of complexity at all. We can just read it off as a basic, just a single byte value. So yeah, S2 is connected to D12 and S3 is connected to D13. Just double checking. Yes, it is. And down at the bottom we've got the output enable going to D8. So basically you raise that to be able to read the frequency off there as well. And as I said, the library will take care of all that for you without any problems. These two wires are a bit, how you doing, aren't they, on here like that? But this is S0 and S1. What they do is, again, you can set these high and low in combination. You see I've actually not wired them to the Arduino, I've wired them directly up to highs and lows here. Depending on what combination of high and lows you put on here, it will alter how what the base frequency of this output is. Again, you don't need to really worry about that. And the way I've set it up, I've set it so that S0 is connected to, I know they're both in red, but S0 is connected to high, so S0 is basically high, and S1 is connected to low or ground. So we've got a high and a low. S0 is high, S1 is low, and that will basically give me a 20% frequency value, which is good for the Arduino to read, for that library to work with. So we don't need to get into that really. They're just wire them like that, and this Arduino Nano will work with this sensor fine. Now the other thing, so that's it, really simple circuit. The other thing is though, when I found it when I was testing, obviously to put a colour against this sensor, you're going to put it somewhere above the illumination of the LEDs, and you're going to try and read it like that over the sensor. Now it's very, depending on what you're going to build, that can be quite difficult to do. You'd be sort of like trying to hold it or something, you're thinking about making some sort of machine, you know, that's quite tricky to just sort of rest it on and what have you. And also, they're sensitive to ambient lighting, so even with these bright white LEDs, in a well-lit room or a slightly dimmer room, you can get different results. So to be a bit more consistent, I built this little shroud, just laid out a little black card, a little black sellotape on, a little gap in the middle, and that just slots over there, like that. And that means I'm blocking out any exterior light sources from different colours or shadows that might be going on there. And I've got a little narrow reading window, so I can just pop whatever it is I'm sampling, the colour, over the window, and then it should only be sampling that colour. And that is, I think, going to be suitable for a lot of projects. Having said that, I have discovered this, it still has, you know, this particular cheap sensor, it still has some limitations on its accuracy. So, I mean, detecting 5 different shades of Skittles colours, which in the UK, in a standard bag of Skittles, we have 5 different colours, which is orange, purple, green, yellow, and red. It's fine. That's enough. Five different colours over the range that we have. It's enough to be able to work out the individual, you know, that each one is different to the other and recognise them. You've had a lot of close shades, or say maybe 10, 15, 20 colours to determine between. It could get a little bit trickier with the accuracy of these devices. So bearing that caveat in mind, we can proceed. So let's move over to the code that I've written, install that, and we'll have a quick look at that. Okay, so let's look at the actual libraries you'll need to install. You can see here at the top of this demo code that I'm going to show you in a little bit that we've got a library called TCS230, and we also need one called frequency count, however you pronounce that, frequency count. EEPROM is actually a library we need, but it's built into the actual Arduino system. You don't need to actually install it, it's already there as a standard library. So if you go to Sketch and Manage Libraries and type in MD TCS230, there you go, that's the library you want by Magic Designs. You can see I've already installed it. And then the other one we wanted was the frequency count, the freak count. And again, I've already installed it. That's the one you want by Paul's, I'm not even going to attempt to pronounce names, but by Paul. So install that one, and then you're good to go. EEPROM, you'll see if I actually do this, EEPROM, it says there, built in, which it is. So you don't need to actually install that or anything, and it's installed, it's built in. So once you've done that, click close. And this code here that you've got, I'll show you, that's on my website, so we'll open up that. So go to external.com, and I mean, you can see it's there as the latest post. Obviously that will always be there. So you go to basics, environmental, and down to where it says color sensor, TCS230, TCS3200. The code will work with either of those sensors. Select that, and you'll get the page up. And if you scroll down, obviously I've written an article about using these sensors, and there's various other things you might want to read on there. Circuit diagram, picture of the actual board as you've just seen. So we scroll down, and there's the code. Click in anywhere, or rather just roll your mouse over and then click that copy icon there. Do a Control-C, and then your empty Arduino project, obviously, I've already got all mine in, you would just paste it into there, and away you go. So let's get the other camera running, and we'll bring up that screen, and we'll have a look at how you actually use this software that I've written. Okay, so to interact with the colour sensor and the software I've written, you need to go to Tools, Serial monitor, open up that, and you'll see the Arduino's now responded and sent some information on the serial monitor. It's telling us there is no black calibration data and no white calibration data, and currently no colours are stored in the EEPROM. So what that means is as well, all the calibration settings and the colours, when we actually store them, are stored in the EEPROM. So when you power it completely off, leave it for several months in a dark cupboard, when you plug it back in, all your colours will still be there and all the actual calibration data will still be there. Calibration is incredibly important. If you don't calibrate your device in the environment you expect it to work in, you're going to get some very poor results. So you have to always calibrate, and as I said, you don't have to do it before every time you use the sensor. For what I've done, you calibrate it, the calibration settings then stored in EEPROM, and when it boots up, it looks for them and reads them back in, sets itself all up, so you're ready to go. You just need to do this once in the environment you're working in. So that's more important really if you didn't have a shroud. So if you were doing this even with these white lights in a bright room, then you went to a slightly less dimmer room, you might find you're going to have some poor results and not brilliant colour scanning. But by using the shroud for a start, you're blocking out a lot of the environmental ambient lighting, or whatever you want to call it. So we can actually, using that, once we still have to calibrate, but once we've done that, should be okay in just about any room, because we're going to literally, like we've show you, the skittle just sits or will sit over the top. So whether it's in a dark room or a light room, I should get consistent results because of the shroud, etc. So first thing we're going to do is calibrate it then with a piece of black card and a piece of white card, so you can see what the darkest colour is and what the brightest is. So looking back here, we've got a calibration menu. So option 1 is to calibrate the sensor. So if you go up here and clicking that little there, you can press number 1. And it'll prompt you, calibrate sensor. It says put a black matte object over the center, followed by any key, followed by return. So what we're going to do is get our black piece of card and just pop that over there. I'll just keep it in place. Oh, that's okay. It's gonna sort of stay. Put my finger down on it, and it doesn't matter. You can press any key you want, and it's scanned the black object. Now it's asking for the white object, so we'll put a white object over, and again any key followed by return. Okay, calibration is now complete. Those calibration settings are stored in EEPROM. Any reboot or power off, power on, and it will read them from EEPROM automatically. So now I want to do a bit of adding colours. So if we look down here, we can add a colour or update an existing one that you've got stored with the number 2 option. So we'll do that. So I'm going to type in 2, let's go with red first. Red skittle on, and press return. Enter the name for the colour, which is red, surprisingly. And that's done. It gives you the RGB value for it, so it's reading the colour red, and it's going to give you an RGB for that. 95 red, 41 green, and 37 blue. So let's go for another colour. So take that off. What's next? Yellow. So I'll just quickly go through these now. So 2, yellow, and scanning, scanned and entered. And green is randomly next. And 2, and green, whack that in. And that's all done. Has it done? Yes, it has. And purple, probably nearly everybody's favourite colour, mine anyway. Even though Skittles apparently all taste the same, so the colour is just there for effect, so I've read. Okay, so 2, enter the name, purple, and get that in. Last one. In the UK, we only have 5 colours of Skittles, unless it's some sort of weird, well not weird, but special edition. Okay, so again, number 2, enter name, what have we got? Orange. Be interested to see if other countries do vary on their colours. I have no idea. So orange is now read in. So we'll reboot this device. In fact, I'll clear the serial output. So we're going to clear output, I'll reboot, and we'll see what it does now after calibration, and we've scanned in 5 colours. So this is the same effect even if you actually power it off and power it on as well. So black calibration has been read in, white calibration is read in, that's great. Colours that have been read from EEPROM are these 5 we've just done with the results that they have. So that's now whether we're powered off or not, that's good to go. So we'll do a test scan, which is number 7. You can see we'll just quickly look at the other options, 3 would display the colours just as we've done up here. 4 would delete an individual colour. I won't go through these, but it'll ask you for the colour. You type in green, it'll delete it. And again, with add update colour, if you typed in an existing one such as purple, it will just confirm you want to override that result, and then effectively you've rescanned purple. And delete all colours does what it says on the tin or on the menu, I suppose, not the tin, menu. It will delete all those colours, and you can clear the calibration settings as well if you want. If you recalibrate, that'll just overwrite them as well. So 7, let's scan a colour. So let's put one on. What do we have? I don't know, start with green, I suppose. So we put it on, press 7. Oops, let's click into the actual area. Press 7. Please work. Of course it worked. 88, green even. So it says that colour is green, and it's told you what it's running, 88, 98 and 52. You can see they're relatively near to those, but not exact, because obviously we put it on maybe in a slightly different place. So let's just test another one. What can we go for? Purple and maybe a red. So let's just put 7 in again to read the colour. And it's read that as red. So purple and red probably need a rescan, because it's not reading them perfectly. So let's just do a rescan on that. How near were purple and red? Let's just type in 3 and look at the colours again. So purple 61. I did scan really high for a purple on that one. Let's just do another rescan on 7. Let's press 7 in again. And that colour is purple. We've now, it's fine, it's got that perfect. That colour is purple. So that's fine. So sometimes you might get the odd glitch. That's one of the few I've ever had. I've not had many, if any, glitches, to be honest, into a lot of software. It's embarrassing when you come to record this, it would actually do one, because basically it has never got the colour wrong until then, which is fantastic when you're trying to do it and record it. So what was that? I put on red. Yep, so that's got red, etc., etc. So let's have a quick look. If you wanted to obviously write your own software to do what it is, a fantastical Skittles sorting machine or whatever it might be, or trying to work out your favourite colour of jumper, you need it to scan it or something, I don't know, whatever weird things people might want to scan colours for, you can. I'll show you the code, and it's very simple to do a colour scan and stuff. I won't show you how things are stored to EEPROM. I think you should just have a look through my code and work that out. It's not too hard, but let's just start with scanning a colour, number 7. So let's go back to the code. And we'll just scroll it down to where Calibrate colour, it's called, is the routine. Now it looks long and windy, but that's because it's doing a lot of things. It's trying to read in stuff from the serial port, etc., etc. But what you could do if you wanted to is use my software to get your colours stored, and then you can rewrite completely new software without any problems. The EEPROM is not overwritten when you write a new program or whatever. It's not reset. So you can store all your colours using my code, and then look at my code for reading those colours back in and our search, and you can just use those bits of mine, cherry pick them, and then for doing the actual scan for whatever sort of thing you're doing, if you actually look down, where's the actual scan? Towards the bottom of this routine, or middle-ish. So to do a scan, you just do this, cs.read. Now CS was an object created back in the setup, so we'll just go back to the top. So CS is here, and that's just an object of that type of class, the TCS230, and we pass it various things, but in this big setup we actually do a CS begin, and then you're good to go. So you've created the object there, you've kind of initialized it there, and then that's it. All you have to think about for that. And then when we come down to the scanning again, so you just do a CS read, and then the important thing to note here with this library, and probably most of the libraries that work with these, it takes it a reasonable amount of time to do a scan. The chip on board there isn't like, you know, a millionth of a second or really fast and instant like more sensors and things we have. It takes a finite amount of time, and this does not wait around. Once it's executed, that is sent the command to the scanner, to the sensor, to the colour sensor. Your code will start carrying on. So if you try and get here, get the RGB, it's probably not going to be ready. Won't be the correct scan colour at all or anything, probably the one before. So right after a CS read, you want some sort of waiting around. Now you can do this in different ways, but for simple code on an Arduino, this is probably what most people use. I just created a while loop here. You've got an available property of the CS object, and basically if that's 0, that scanner, that sensor is busy. So this executes around and around, and when it's it's available, we know we've done a complete scan, and then you can get your RGB colours with that. And then you've literally got them. And they are in this format, RGB.value, which is, the value is just an array between 0 and 3, I think it is. And you just pass it one of these constants to read red, to read green, to read blue. And it will return an integer value, well, it is an integer value, but a byte value between 0 and 255. You can see when I start to try and store them out to EEPROM here, I just have my own red, green and blue, because I just find that just a bit easier on my head and just simpler to read. So I just read them straight into there, into that object, and then I write that object out to EEPROM. So that's the basics of colour scanning. If you do want to calibrate, write your own software and have the calibration routine in, then that's pretty much the same. Here's the Calibrate sensor routine just there. And again, we do a CS read. We wait again until it's finished doing its reading, and then we use a CS get raw value. And then I just set that to the dark colour. So that's presuming I put the dark on first. And then a little bit later on, we do the white, so we do a read again. I wait again, I get the raw. And then with that raw data, that SD there, I just write it to the white calibration. Presume it was the white object that was placed over there. And that's it for calibration. So they are quite simple. They are probably the more just slightly convoluted bit is just the fact that, you know, you really want to be storing these values in EEPROM. You don't want to have to rescan colours every time you want to use your software and things like that. So you can have a look at how I've used the EEPROM in these routines here for storing the calibration data and for storing the colour data just down below as well. That's pretty much it. But have a look through. Hopefully you can create your own project now with that as a starting point. And yeah, until next time, thanks very much for watching. Thanks to all my patrons, and catch you next time. So if you like that video, hit that thumbs up. If you really like to see some more, hit that subscribe button, followed by the notification bell so you see all the videos that are uploaded, and hit that share button if you're into that kind of sharing thing. If you'd like to become a patron, there's a little icon will come on the end screen, and you can go to my Patreon page. I release videos around 24 hours early for Patreons, and I actually put little posts and updates and things on there and pictures of ongoing projects as well a few days early for the rest of the world. So thanks very much for watching this video. Hope you can watch some more, and until next time, stay loose. Stay loose. Did I really just seriously say that? Let's move on. Let's roll the end titles. Let's stop. End the video.